Alright, so this is what your table should look like from last night. These areas right here were all areas of a square, so they should have been perfect squares, 16, 25, 36, 49. And then the new rectangle, you were taking your original side length and adding 2 for the new length, and then you were subtracting 2 for the new width. And then you just had to multiply length times width for all of these to end up with the new area. And then the difference in area, you were taking your original one, so like the 16, and subtracting 12, and that's how we ended up with 4. And then do the same thing, 25 minus 21 gave us 4. And then your questions, it says, explain why the table starts with a side length of 2 rather than 0 or 1. So if we would have started with a side length of 1 here, we could have done the add 2 part, our new length would have been 3, but when we had to subtract 2, we would have ended up with negative 1, and that obviously can't happen if we're talking about an actual rectangle. And then 0 is the same reason why. Question 3 says, for each side length in the table, the final column compares the area of your new lot with the area of the original lot. For which side lengths, if any, is this a fair trade? And hopefully you figured out that these are all exactly the same, but that means none of them make a fair trade. You're always going to end up with 4 less square meters than if you were to stick with the original square. So part B, we're going to write equations for both of these. So the first one says, write an equation for the relationship between the side length n and the area A1 of the original lot. Remember that the original lot was a square. So if you have a square with a side length of n, all of the side lengths have to be n. And then if you want to find the area, you can do 2 side lengths multiplied together, n times n. And then we can write this as n squared. So there's your formula. The area for the square is n squared. Now the next one's a little trickier. We need to write an equation for the relationship between the side length n of the original lot and the area of the new lot. So when we have our new rectangle, we did 2 different things. For the length, remember, we took what we had, the side length, and we added 2 to it. And then for the width, we subtracted 2. So we can write that mathematically as we took our original, the n, and we added 2. And then for our width, we took our original, that n, and we subtracted 2. Now if we want to find the area, remember we just have to multiply length times width. So the area of our rectangle can be the length, which is the n plus 2, times our width, which is n minus 2. And I can give you any n, so we could go back to our table, and let's say we wanted to look at like the side length of 6. We know we're going to end up with a length of 8 and a width of 4 in our new rectangle. So if we were to plug in 6, we'd have 6 plus 2, which gives us that 8, times 6 minus 2, which gives us the 4, and that's how we can end up with the 8 times 4 that we had, or 32. So question 3 says that Carl came up with another expression for the area of the new lot. Is this possible? Of course it is, but we need to figure out what that other expression is. So think back to what our table told us. We've dealt with the plus 2 and minus 2 part, but let's relate it to the differences in areas. Hopefully you noticed every single time our rectangle was 4 less than our square. So if we think about what this means in an equation, we can take the area of our square and we can take away 4 every single time. So remember, the area of the square minus 4. And that happened for every single rectangle that we had. So the area of our square, if we go back up here, was n squared. So that's what we're going to plug in down here, n squared. And then we're going to take away 4. And that, again, will work every time if we compare our table. So if we go back to the one that we used, that 6, the area of our square was 36. And if you take away 4, you end up with 32, which is what we had for the area of our rectangle. So flip the page over in your notes. And you guys are going to graph these two equations. The two equations are this one, the n squared, and then these two, remember, mean exactly the same thing. Both of these are for our rectangle. So pick one of them, either this equation right here or this equation right here. Doesn't matter. You're going to graph one of those, and then you have to graph the one of the square. So this equation right here. And I'm going to have you do this on that website that I showed you the other day, the Desmos website. So if you read in your notes, it tells you how to make the window for the independent variable. You want to go from -10 to 10, and for the dependent variable from -10 to 30. So go to desmos.com, DESMOS, and you want your window to be set up just like it tells you in your notes. The x is your independent variable. It needs to go from -10 to 10. Your y is your dependent variable, and it has to go from -10 to 30. And remember, you can change the window by clicking on that wrench up there at the top. So once you get that, you need to go over to 1 and 2. Those are going to be the two equations that you plug in. And you're going to plug in both of the things that we found. When you click on this, a y equals will pop up. And then remember, we used n for the side length, but you have to use the variable x on there. So you can type in x, or you can pull this keypad up, and there's an x on there that you can use. First one was n squared, so we're going to type in x squared. You want to graph that. And then graph the next one. And remember, you could plug in x plus 2 times x minus 2, or you could plug in the x squared minus 4. These will give you the exact same graph. So once you have both of them graphed on there, you need to go back and answer these questions in your notes. For each graph, tell which part of the graph makes sense for the situation. Sometimes you're going to have x's in the negative land, and remember that's talking about length and width, which doesn't make sense. And then describe any similarities and any differences in the two graphs. And then answer, are either of these quadratic? And that's what we've been talking about with our parabolas lately. So you have to do this on your computer right now with the new website that I showed you, the desmos.com. When you get all of this done and your notes are filled out, you can start on the homework, and that's what's written, bullet number 3 on the board, and it's on your stamp sheet from Thursday's stuff. Page 31, 50, 51, and 56. Some of it's review of stuff that we've done a while ago. And then when all of that's done, you're going to have Miss P mark on the stamp sheet that you did it, and then if there's time left, you can play cool math games.